Hey, this is Josh, and today we're going to be simplifying radicals or square roots, okay? But we're only going to be dealing with expressions in this section. If you don't know what expressions are, remember those are the ones where there's no equal sign. It's just a bunch of stuff that you're kind of condensing down, okay? Different teachers teach it different ways, so I want to show you both methods, at least the most common methods, so that way you can kind of pick and choose whatever way works best for you, okay? When it comes to simplifying square roots, if we have a square root here of a number, like, you know, we'll just say a times b, or the square root when you're dealing with fractions, you could have a over b. The only rule that really needs to apply to these is the fact that one of these values can't be equal to 0, because if it is, then it's like you're ending up with a 0. How do you take a square root of nothing? You can't, okay? But we have our product and quotient properties here. I just wanted to mention those just so you understand that you can't have a 0 anywhere in this type of a problem, okay? So the first way for you to figure out these things is, let's start off with something small like the square root of 9, okay? You could use a calculator, right? Which is going to work pretty darn fast, because you could just take the square root of 9, put that in your calculator and get 3, okay? But you could also use the method of creating a factor tree, because the square root of 3 times the square root of 3 gives you the square root of 9, okay? Now let's make the number a little bit bigger. Let's make it 20, okay? So now we got to do a little bit extra work, because the square root of 10 times the square root of 2 is 20. I mean, I could have used 5 and 4 at the same time. Now, some teachers are going to push you to only use perfect squares here, because that way, if you get a perfect square, like square root of 9, then you end up with a 3, okay? I don't want to make this complicated, okay? I'm all about the efficiency, right? Okay, so let's just keep working on this and we'll talk about what I meant. We have the square root of 5 times the square root of 2, okay? So we've broken this guy down into all of these parts. And in order to simplify this square root or radical, whatever you want to call it, you need to get stuff out from underneath here and get it out from under the square root sign. So I say what you do is you pull out the doubles, okay? And what I mean by doubles is anything here where you have more than one of them, okay? Where you have 2, actually. So because I have square root of 2 and the square root of 2, well, if I multiply those, what is the square root of 2 times the square root of 2? It's just 2, right? Kind of like here. The square root of 3 times the square root of 3 is just 3. And we know the answer, the square root of 9, is 3. So it works. But you pull out your doubles. And when I say pull them out, I mean pull them out from underneath the square root sign. Okay? And whatever's left here just stays. Okay? So it doesn't matter what's here. Okay? It doesn't matter if you had a 5 and a 7 and a 15, 17 or something. If you have a bunch of stuff that's still left over, that's okay. Just multiply them all back together. Put them back underneath the square root sign, okay? Let me do one that's a little bit bigger. Let's do, how about 48, okay? Now, when you bust these apart like this, it doesn't matter what factors you use, okay? I could use, and again, it just makes it easier when you use numbers that you're comfortable with. So if you look at that and say, well, I know I can break it in half and do a 2, right? Then do it, okay? If you know that that's 8 times 6, then use 8 and 6. If you want to do 2 and 24, then do 2 and 24, okay? I'll do 2 and 24, 2 and square root 24, okay? So we have this part done. And then I need to now keep going, because that can be reduced. Let's see here. I could use 8 times 3, 6 times 4, 12 times 2. Again, know your math facts, okay? They're gonna save you a lot of time versus you just sitting there with a calculator going, what numbers are gonna make a 24, okay? I'll use 6 and 2. I'm sorry, 6 and 4, okay? I have the square root of 4 and the square root of 6. A 4 can be broken down into a square root of 2 times the square root of 2. A 6 can be broken down into a square root of 3 times the square root of 2, okay? And then from here, you pull out your doubles, right? Oh, I got one right there. So that's a 2. And I got another set of doubles. I got these 2 guys right here. And that's another 2. And then I got a 3 that's left over. And as we talked about, anything that's left over just goes right back over on that side, okay? What's important is we deal with these guys, okay? So we've pulled out a 2 times a 2, but these are all factors. And so because of that, we can multiply them back together to come up with a final answer like that, okay? And so what we've done is we've simplified square root of 48 down to something else. And you might be saying, well, why am I even doing this? Like, what does this have to do with anything? Well, it really is a tool. And so as you get into more complicated problems, there's going to be times when you have the square root of 48 as like part of this giganto problem you're working on, and you need to say, oh man, I can bust that thing into 4 square root 3, because then I can like cross stuff out or simplify even more because I'm not just dealing with this big number. Okay, so as you get more complicated problems, this is going to become very handy. Okay, and so this is how we reduce or simplify a basic radical expression. Okay, thanks for watching.